All right, everybody. So for this lecture, this is live sound basics, getting signal to the PA system. So just bear with me. I have a lot of slides and a lot of content to go to and not much time. So by definition of Yamaha, a sound system is a functional arrangement of electronic components that is designed to amplify sound and is designed and created for the following three main reasons. One is to help people hear something either through reproduced or broadcasted means. Second is, my favorite, is to make sound louder for artistic reasons. And three is to enable people to hear sound in remote locations, like, for example, sending a signal to a remote room to play on a stage performance that is happening in the main room. And so it can get complicated as we look at these slides and these stage plot diagrams, and it can get as complicated as we need to be. But in reality, all we have to remember is three main things. Number one is our inputs. Getting input is the main thing, and if we don't have that, we're not going to have any sound. And that's our mics and pickups that we'll cover later on in the slides. But what we're really doing is converting acoustic energy into an audio signal for processing. And that's number two, is signal processing for preamplification. Equalization of the signal for balance, which is our corrective means to get sound correct for our audience. And then mixing to produce a single line level output signal, hence the term mixer, which is where all the processing happens. And then the third thing is using our output transducers, which is our PA system, and our monitor speakers, which convert the power amplified electrical signal back to acoustic energy. So something interesting is that it starts out as acoustic energy and then it leaves through the PA system as amplified acoustic energy as well. So our signal flow basically is like this. We have our sound field, which is our source input, which creates this energy, but it's very, very low. Low to the level of about negative 40 dB on average, depending on what kind of mics you're using. And it can vary because there's certain mics that will process signal or help to process that signal a little bit higher. But for sake of argument, it's about negative 40 dB, which is inaudible to the ear. Acoustic energy is then converted to electrical energy via the input transducer, which we've already covered. And then for live sound, it's through air pressure and velocity microphones, as well as contact and magnetic pickups for instrumentation, like an example, a bass guitar and electric guitar, which convert sound into audio signal either through sound waves, through mediums like wood or metal, or magnetically. And then this creates the audio signal to send to your mixer via XLR cables, but the signal is still at mic level and needs to be amplified to line level. If we don't do this, we cannot force the signal past the components of the PA system, and basically we can't move the cones of the speakers to hear anything. So we need to amplify the signal. So once the signal reaches the board, it's ready for amplification and processing, which is done at the mixer. Some mixers are sometimes, depending on how complicated we want to get with this conversation, can be done at an external hardware gear as well. Amplification at the mixing board is also known as HA for head amp or PA for preamp, and is the first step in processing from your mics and pickups and your instruments. The purpose of the mixing console is to add preamplification, equalization, and mix the signal to a single line level output to get to our PA system. The second part of the signal processing occurs, which is electrical manipulation of the audio signal, either through EQ, compression, reverberation, or many, many other effects used to both correct the sound so that it's balanced and desirable to the ear without harshness. And so it also creatively creates a creatively manipulated sound that creates specific moods and feelings. For this topic, we won't go into like ringing out rooms or the creativity part, because right now we're just trying to get signal to the PA system so that we can start the creative process, and then after that, the corrective process beginning first, and then the creative process after. After signal is amplified from the console, it is now considered monitor level signal, which is what is finally needed to move the speaker cones, and is boosted from anywhere from 0.1 to 100 milliwatts up to 0.5 to 500 watts, or much, much higher, as we'll get into shortly. Your SPL levels will tell you how loud your monitor signal level is that you can use on your phone or on your console, some of them, depending on what you want to use. Next, the mixed and processed audio signal is then sent through the output transducers for the electrical to acoustic energy conversion. The function of the output transducer is to basically convert the power amplifier output signal back into sound so that we can hear it once it gets to that state. Output transducers include the system subwoofer, woofers, mid-range, your tweeters, your full-range monitors, your super tweeter loudspeakers, as well as your headphones also, which is something that a lot of people don't remember and was usually used for mixing. So here's a dBA reference chart that shows basically what dBA levels and what certain events are happening at those levels. So if we look at 10 dB, we can look at a pin dropping. So 0 dB is like basically what a newborn baby hears at 0 dB. It's like perfect human hearing. The now processed acoustic energy is then sent back into the sound field via output reproduction. Only now the processed and amplified starting from negative 40 dB with the signal at the input source to 130 dB plus at the PA, depending on who's playing. Some people louder than others. So it's the difference between a pin hitting the floor and an air raid siren. So this is the wall of sound, which is, they've clocked it at like 127 dB, which is pretty loud. So that's that. I thought that was interesting to show. And it pushes out about 28,800 watts of power. Okay, so basic live sound components. So getting the signal to the PA, you have to know what goes where and when. So the input list for your show, I won't cover this in depth because we kind of already did this in our integration project. So it's the basic input list for this, as you can see, it's like your drums and all your stuff that goes on stage, right? In your DI boxes, stage box and stage snakes are pretty important because it's how you get everything back to the console without having to run cables everywhere. You can do it simply through a snake or a stage box, or both. And so then we have a bunch of other things like our FX racks and network switches for our mic systems. And then a lot of people kind of forget about multi-track recorders. Also, you can use that for live sound as well to record your sessions. It's good for reviewing afterwards what you, how you mixed your show and things you can improve on and what went well. And then your monitors and PA systems, choosing the right speaker for the venue. Don't overpower a room, don't underpower it. It's kind of a balance. Know your speakers. And then the mixing and monitor consoles. They have a bunch of different names for this conversation. We're just calling them mixing consoles. Double check your routing ahead of time and know your boards. This is really important. So RTFM, as we talked about in class, if you don't know what that means, it basically means just download the PDF and read about your board. Insist on sound checks. I've come across a couple bands lately that just wanted to go right into it, but what happens is that kind of harms you or puts you under unnecessary tension because now you have to kind of EQ and figure out everything on the fly. It's awesome training, but it's also terrifying at the same time. So I try to insist on doing it, and if not, do the best as you can on your own or have somebody kind of test run your system on your mic checks and stuff like that for you, or if they have spare equipment around or instruments, have them set up real quick and do a sound check that way. I won't get into the subs. It's usually just patch the mono channel and stereo. So we don't really patch subs to stereo because it usually causes phasing problems, so I tend to stay away from that when I'm patching things into the mixer for better sound. And also be prepared that when you're learning your consoles, be prepared to also be the monitor, to be on the monitor console as well, or be able to patch between both on the same mixer. I've been having to do that lately, and it's just extra work. It's not, it's not a big deal. Just be prepared to know the board to the point where you can actually switch between your PA and your monitor system. So on the mixing console, I'll keep it super simple on this. This is a Midas that I use, but it's like the 1604 Mackie that we used in live sound class. looking at it from that perspective. The signal flow usually runs from the top of the channel down the EQ strip down to the channel fader, depending if you have pre or post fader selected. Auxiliary signal flow usually runs from left to right. Turning up the aux control knobs will send the aux signal to the aux master fader. Your aux groups is also where you control your FX. Group controls can send processing to a group of instruments patched to that group, like drums. Millions of ways to set this up on the session, but the aux sends are used usually to send signal to the monitors and PA system, and FX and channel fader is used independently to control volume. I like to do this because a band might tell you they need more reverb on, say, a kick drum, for example, and if everything's tied to post fader, you don't want to raise everything up at one time because they might not want more volume, they might just need reverb. So just keep in mind that the more complicated your workflow is, the more familiar you should be with that console. Troubleshooting, have the right tools to check for continuity and signal. So this, I put these together based on things that I've run into in the past. Not having the right tools or sniffers and stuff like that to check XLR signal, a lot of times it's just a bad cable and it doesn't look bad. So it just fails for whatever reason. So always be ready to test that stuff, or a multi-tester to check power. Have a repair kit available with extra parts for your video and lighting, especially with cables. It does seem to fail more than anything because they get kicked around a lot, especially in live sound. If you're not getting signal to something or power, always start with the basics and look, is everything switched on? Is everything connected properly? Is my signal flow correct? Did I accidentally plug something into an input when it should have been an output? Double check all your signal routing and signal flow. And I usually start at the mixer and then go out. And it kind of keeps things simple for me to remember where signal is going from the mixer out. Check for damaged cables, use a sniffer, make sure all components are turned on, and understand your equipment, and have manuals ready for you to reference. They're available for free online as PDFs almost for everything that I found. And that's pretty much it. Anybody have any questions?
Who was the band that decided not to do a sound check?
That's these guys up here. And so when we were trying to get signal, one of them went missing because he went out drinking, and the other one was just socializing with everybody. And they just wanted to start and go right into it. So I had to EQ and everything on the fly, which was actually a lot of fun, but it was a tough session because their dynamic range was really wide. So that's really where knowing your EQ on your mixers and all that, and having fast workflows is really super important in case stuff like that happens, because the bands are unpredictable, and sometimes they want to be really loud, sometimes they want to be really quiet, and so they'll do anything. So just be prepared for the inevitable. Thanks, guys.